The most accepted theory of the creation of the universe and life itself is the Big Bang Theory. The Big Bang Theory states that about 15 billion years ago, a huge explosion began the creation of the universe. When the Big Bang occurred, the particles that make up today's universe were violently pushed apart. Two major pieces of evidence for the Big Bang Theory are the redshift of galaxies and cosmic microwave background radiation. The redshift of galaxies is important to the Big Bang Theory because it proves that the galaxies are indeed moving away from each other, a movement resulting from the initial outward explosion. The redshift of galaxies is a result of the Doppler effect, the same effect that stretches and compresses sound waves and results in a change of tone. Light waves moving away from the viewer are stretched out, increasing wavelength and shifting the color to red. Red light has the lowest frequency of the visible spectrum, which is why increasing the wavelength makes a galaxy appear red. The red color of a galaxy's light is, therefore, a clear indicator that it is moving away from us. Just as important as redshift is cosmic microwave background radiation. Accidentally discovered by radio astronomers Arno Pienzas and Robert Wilson, pictured here with their Holm-Del-Horn antenna, microwave background radiation is believed to be remnants of the Big Bang. The measurements taken of variations of microwave background radiation perfectly fit the model of what should be left over after an explosion the caliber of the Big Bang. This small remnant of the Big Bang can still be seen today, as a very small portion of television static. Now that we've covered the creation of the universe, what about life on Earth? Most scientists believe that life on Earth began in the oceans in the early years of our planet. These two images are pictures of early marine life. The one on the left is an image of stromatolites, Earth's oldest fossils. On the right is a prehistoric marine creature, a pterodactyl, from the mid-Cambrian period. These fossils, along with thermal vent ecosystems, help to prove the oceans to be the cradle of life. Thermal vent ecosystems are extremely hot and seem almost inhospitable to life. The animals here, however, thrive in the depths of the ocean. The producers create energy through chemosynthesis rather than photosynthesis, as no light reaches the depths. Vent life relies on hydrogen sulfide, which is produced by thermal vents themselves. These ecosystems are ancient, and their existence helps prove that life began in the oceans. The conditions of vent ecosystems are guessed by scientists to be very similar to conditions on early Earth, and the ability of life to thrive in these conditions seems to prove that early life must have been very similar to the aquatic vent creatures seen today. Another major piece of evidence for life beginning in the oceans is the fossil record. The fossil record is the layer of fossils built upon each other. The newest fossils are towards the top, while the oldest fossils are at the bottom. Early ocean bacteria, including stromatolites, are at the very bottom of the fossil record. In fact, ocean fossils occur way earlier in the fossil record than land life. The older age of ocean fossils suggests that ocean life came first, and that land life eventually originated from the oceans.